Hi friends, welcome to TechnoSteve. This is the second part of mechanical MCQ and answers. Okay, let's start. First question, what is the loading? What is the loading in grinding operation? In grinding operation, loading is represent what? That is, we know that the space between the consecutive grains is called structures. When ductile materials is grained with a closed structure grinding wheels. Okay. So because of that, long chips will produce. Because of the grinding process, that long chip will produce and it will forcefully enter into the structure. Okay. So that the space gets blocked. Because of that, the space gets blocked and grinding will simply run with the workpiece and there will not be any material removal will happen. This situation is known as loading of grinding wheel. Okay. So the right answer from the option is chip clogged around the abrasives. Okay. The chip will the chip will clog in the abrasives or the structure in between the structure. Okay. Next question. While cooling, a cubical casting of side 50 mm undergoes 1%, 2%, 3% of volume shrinkage during the liquid state, phase transition state, and solid state respectively. The volume, then find the volume of metal compensated from the riser. Okay, the volume of metal compensated from the riser. You need to calculate. You know that risers are used to compensate shrinkage before solidification. Okay. That is liquid shrinkage and shrinkage during phase change. Okay. Therefore, volume of the metal compensated from riser will be equal to 1% for liquid state and 2% for the phase transition state. That will be equal to, that is the sum of the 1% and 2%, that will be equal to 3%. Okay. The volume of metal compensated from the riser is 3%. If given the relation of sigma is equal to 1000 epsilon raised to 0.4, then the average stress is equal to okay, the relation sigma is equal to 1000 epsilon raised to n. That is the relation between true stress and a true strain relation. Okay. Here sigma is the true stress. Here the 1000 which is represented is strength coefficient, and true is the true strain, and 0.4 is the strain hardening index. Okay. The relation between true stress and true average stress is sigma T equal to sigma T, or true stress equal to average stress into 1 plus n. Okay. We know that the equation true stress is equal to K into epsilon raised to n. That will be equal to sigma average into 1 plus n. From that, sigma average is equal to K into epsilon raised to n divided by 1 plus n. Substitute the value of strength coefficient and true strain and strain hardening indexing value. From that we will get 1000 epsilon raised to 0.4 divided by 1.4. Okay. So from that we get the answers. Option D is the right answer. Which of the following measuring device is used to measure cutting force? Cutting force. For measuring dynamometer. Dynamometer is used to measure the cutting force. Autocollimator is using for flatness of the surface. Autocollimator is using for the flatness, to check the flatness of the surface. Okay. Anemometer is using for velocity of air, to find the velocity of air, and hygrometer is using to find the humidity of the moist air. And hydrometer, but the hydrometer is using for finding the specific gravity of the liquid. Next question. Wet bulb depression is equal to. Wet bulb depression is the difference between dry bulb temperature and wet bulb temperature. Okay. The option A is the right answer. dBT minus WBT is equal to wet bulb depression. Next question. A steel bar of 50 by 50 millimeter square cross sections is subjected to an axial compressive load of 200 kilonewton. The length of the bar is 2 meter and Young's modulus E is equal to 160 gigapascal. Then the magnitude of deformation of the bar will be, that is delta L, we need to calculate. Okay, this is a compressive load. In this question, the load is compressive load. Length is equal to 2 meter. Area of cross section is given. Load is given. Load is also given. Young's modulus is also given. So the relation between delta L and the load is deformation of the bar delta L is equal to PL by A. All the parameters are known. Substitute the values of PL and AE. From that we can find the deflection delta L is equal to 1 millimeter. Next question. Essential gradient of any hardened steel. Essential gradient of any hardened steel is. Answer is martensite. We know that martensite is formed in carbon steel by rapid cooling of austenite form of iron at such a high rate that carbon atoms does not have time to diffuse out of the crystal structures in large enough quantities to form cementite. Okay. In a reaction turbine, the enthalpy drop in a stage is 45 unit. The enthalpy drop in moving blade is 23 unit. Then the degree of reaction is. The equation for the degrees of reaction are equal to enthalpy H, enthalpy change or enthalpy drop in moving blade divided by enthalpy drop in the stage. That will be equal to 23 by 45. That will be equal to 0.511. Option B is the right answer. Next question. At a point in 2D stress system, sigma x is equal to 130 Newton per millimeter square. Sigma y is equal to tau xy equal to 40 Newton per millimeter square. What is the radius of the Mohr circle for the stress problem with a scale of 1 centimeter is equal to 10 Newton per millimeter square? For this question, first we need to draw the Mohr circle diagram. First, sigma x is given. and sigma y also given. Mark these points sigma x and sigma y on 30 and 40 respectively, and draw tau xy in upward direction. Mark the point 40 above and tau yx the same 40 below also. Then join these 2 points and then we will get the center point of the Morse circle diagram. From that we need to draw one circle. The Morse circle. The radius will be equal to square root of the half of between 2, that is 130 minus 40 divided by 2 whole square plus 40 square. Using Pythagoras theorem we can find the value of radius r. That will be equal to 60.21 Newton per millimeter square we will get. For 1 centimeter it will be around 10 Newton per millimeter. For 60 Newton per millimeter square, that will be almost equal to 6 centimeter. So the radius of the Morse circle will be 6 centimeter. Option D is the right answer. Next, the brakes applied to a car moving at a 24 meter per second produce an acceleration of 6 meter per second square in the opposite direction. The motion. If the car takes 2 seconds to stop after the application of the brake, the distance traveled by the car is. Okay. In this question, the equation of motion is equal to ut plus half at square. We need to apply this equation for this problem. The initial velocity u is given 24 meter per second. Acceleration, that is in opposite to the direction of the motion, so the minus 6 meter per second square, and the time to stop is 2 seconds. The values are given. Substitute this value to the equation, and from that we will get the distance is equal to 36 meter. The C is the right answer. A shaft of diameter d is subjected to a torque T to have the angle of twist 4 times as that of before. The percentage reduction in diameter is. Okay. For this problem, torsion equation is, we know that the torsion equation is T by J is equal to tau by R, that will be equal to G theta by L. Here the torque is same. Okay, and the shaft diameter also same, but the angle of twist is 4 times of the before. Okay, so we need to find the relation between angle of twist and the diameter. So from that we will get T by J, that will be equal to G theta by L. We need to consider that equations. Okay, from that the relation between theta, angle of twist theta, and the diameter is theta is directly proportional to 1 by J, that is theta is inversely proportional to polar moment of inertia of the shaft. Okay, so from that we can write theta 1 by theta 2 equal to polar moment of inertia of the second shaft divided by of the first shaft. The polar moment of inertia is directly proportional to diameter raised to the power of 4. So J2 by J1 will be equal to d2 the whole raised to 4 divided by d1 the whole raised to 4. So here the question is mentioned the angle of twist in second is 4 times of the first, that will be equal to 4 times of theta 1 equal to theta 2, and from that we will get the d2 will be equal to d1 divided by root 2. The percentage of reduction in the diameter is equal to percentage of reduction in diameter. Here diameter of the second shaft will be less than that of the first shaft. So percentage reduction in diameter will be equal to d1 minus d2 divided by d1 into 100%. From that, substitute the values of d1 and d2. From that we will get around 29.28, that will be almost equal to 30%. Okay, 30%. Option B is the right answer. Lancashire boiler is fire tube, is a type of fire tube boiler. The fire tube boilers are what? The fire tube boilers are the boilers. The hot gases from a fire pass through one or more tubes running through a sealed container of water. That is fire tube boiler. Next question. A heat engine receives 1000 kJ of heat and produces 600 kJ of work. The amount of heat rejected in kilojoule and the efficiency percentage of the engine respectively we need to calculate. Here heat supplied is given 1000 kJ and the work transfer is also given 600 kJ. So the efficiency is work transfer divided by heat supplied, that will be equal to 600 divided by 1000, it will be equal to 60%. Heat rejected will be equal to how much heat supplied minus the work produced, that will be equal to 1000 minus 600, that will be equal to 400 kJ. Option B is the right answer. Next question. A roller contact type bearing has a rated bearing capacity of 20,000 Newton and a design load of 4,000 Newton. The speed of the journal is 600 rpm. Determine the life of the bearing in millions of revolutions. Okay. Here the life of the bearing in millions of revolutions, that will be the equation for that life of the bearing is L is equal to C by P the whole raised to K into 10 raised to 6. Here C is the dynamic load capacity and P is the applied load. Here the dynamic load capacity is given 20,000 Newton and the applied load is given, design load is given 4,000 Newton. Okay. The K value is a constant value. For a roller bearing we need to consider 10 by 3 or 3.33 will be the K value, and for ball bearing K value will be equal to 3. Here life of the bearing, life of the roller contact bearing, so roller bearing L is equal to 20,000 divided by 4,000 the whole raised to 10 by 3 into 10 raised to 6, that will be equal to 213 into 10 raised to 6 revolutions, that is 213 millions of revolutions. The answer is 213 millions of revolutions, that the options Option is D. The correct answer is D. 213. Next, the cycle generally used for petrol engine. For the petrol engine, using Otto cycle. Otto cycle is the right answer. Which cycle consists of two reversible isothermal and two isochoric processes? Okay. Cycle consists of two reversible isothermal and two isochoric processes. Okay. Two constant temperature process and two constant volume process. The answer is Stirling cycle. Okay. Find the modulus of elasticity of the rod which tapers uniformly from 30 mm to 15 mm diameter in a length of 300 mm. The rod is subjected to axial load of 5 kN and the extension of rod is 0.022 mm. Okay. Here we need to know the equations for delta L. Delta L is equal to delta L, the deformation or the extension. Delta L is equal to PL by A. Here area A will be equal to pi by 4 the capital D, the first initial diameter, higher diameter, and the final diameter, D into final diameter, small d. Okay. That is pi by 4 capital D into small d. We need to consider for cross-sectional area A equal to pi by 4 capital D into small d. Okay. Substitute the values of delta L is equal to 0.022 millimeter and P also given 5000 Newton and L 300 millimeter. Capital D, larger diameter D is equal to 30 millimeter and small diameter D is equal to 15 millimeter. Substitute the values of this and find the values of E, Young's modulus E equal to, that will be equal to 1.929 into 10 raised to 5 Newton per millimeter square. So the answer is option C. In a fillet weld joint, the weakest area of the weld is weakest area. In a fillet weld joint, the weakest area of the weld is, that is throat. Throat is the weakest area. Throat in fillet welding, throat is the minimum cross section of the weld located at a 45 degree to the leg dimension. So the maximum shear stress will develop at the throat only, and because of that the failure will happen at the throat of the weld. Option is C, throat. An open system is on in which an open system. On an open system, both the energy transfer will happen. On energy transfer and mass transfer also will happen. Option C is the right answer. Both the energy and mass crosses the boundary of the system. Okay. That is the right answer. Two involuted gears in mesh have a module of 7.5 millimeter and a pressure angle of 20 degree. The gear has 60 and pinion has 32 teeth. The ratio of sliding to the rolling velocity at the pitch point, considering addenda on pinion and gear wheel as one module. Okay, the ratio of sliding to the rolling velocity at pitch point. We know that at pitch point the sliding velocity is 0. So the ratio between the sliding and rolling velocity will be also 0. Option is 0. Option is D is the right answer. Next, consider a system of two identical particles. One of the particles is at rest and the other has an acceleration of a. The center of mass has an acceleration. The acceleration of the center of mass a is equal to m1 a1 plus m2 a2 whole divided by the sum of the masses m1 plus m2. Here m1 will be equal to m2, that will be equal to m, and first body's acceleration a1 is equal to 0, and the second particle's acceleration a2 is equal to a. So acceleration of the center of mass a is equal to cm is equal to, substitute the values of this to the equation, and then from that we will get a by 2. Option B, a by 2 is the right answer. In order to facilitate the withdrawal of pattern, for easy removal of pattern, we need to give the allowance for the pattern. Which allowance we need to give? We need to give draft allowance. Right answer is draft. Draft is provided on the pattern. Okay. Thus, draft is provided for easy removal of pattern from the mold. Generally, we are giving the draft angle is 1 degree. Okay. Option B is the right answer. Next, a spring mass damper system. The mass is 5 kg and undamped natural frequency is 40 Hz. What is the value of critical damping coefficient? The equation for critical damping coefficient is Cc equal to 2m omega n. Okay. Here undamped natural frequency is given. Undamped natural frequency is f. Frequency f is equal to, that is in Hertz, 40 Hz. We know that the relation between undamped natural frequency and natural frequency omega n is omega n equal to 2 pi f. Substitute the values of f and we will get omega n is equal to 80 pi radians per second. Okay. Omega n we find out, and m also there, mass also there. Substitute the value to the equation. From that we will get the Cc, critical damping coefficient Cc, that will be equal to 2514. Option A, 2514 Newton second per meter. That is the right answer. Next, which one of the following numbers represents ratio of kinematic viscosity to the thermal diffusivity? Kinematic viscosity to the thermal diffusivity. Okay. Kinematic viscosity is the ratio between dynamic viscosity and the density, the mass density of that particular fluid. Okay. And for thermal diffusivity is the ratio between thermal conductivity divided by density into Cp. Okay, that's the relation. So the ratio between kinematic viscosity and the thermal diffusivity is the Prandtl number. Prandtl number is the ratio between kinematic viscosity and thermal diffusivity. That is mu Cp by K. Mu Cp by K. Mu is equal to dynamic viscosity. That is the Cp is the heat capacity at constant pressure. K is the thermal conductivity of the material or particle. A 0.5 meter diameter pipe bifurcate at a Y section into two branches 20 cm and 40 cm diameter. The rate of flow in the main pipe is 0.6 meter cube per second, and the smaller diameter is 0.25 meter cube per second. Determine the velocity of flow in 40 centimeter pipe. Okay. First, we need to draw the figure. Okay. From that, we need to calculate. We need to find the velocity through 40 centimeter pipe. That total discharge Q1 is equal to the sum of the branches discharge from the branches, that is Q2 plus Q3. From that we can find the Q3 value, that will be equal to A3 into V3 according to continuity equation. Apply the continuity equation on the 40 centimeter pipe. Q3 is equal to A3 into V3. A3 is equal to pi by 4 d square. Diameter is equal to 0.4 meter whole square into V3. From that we can find the value of V3, that will be equal to 2.785 meter per second. Option C is the right answer. Next, a self-service store employs a cashier at its counter. 9 customers arrive on an average of every 5 minutes, while the cashier can serve 10 customers in 5 minutes, assuming Poisson distributions for the arrival rate and exponential distribution for the service rate. To find the average number of customers in the system and the average queue length respectively. Here, average number of customers, that is the length of the system. And the length of the queue. So we need to calculate. Here arrival rate is given 9 customers in 5 minutes. That is arrival rate lambda is equal to 9 by 5, it will be equal to 1.8. The service rate is 10 customers in 5 minutes. That will be equal to 10 by 5, it equal to 2. The average number of customers in the system, or the length of the system, is equal to lambda by mu minus lambda. That will be equal to 1.8 divided by 2 minus 1.8 will be equal to 9. Next, average number of customers in the queue, that is length of the queue without considering the cashier. Okay, length of the queue equal to lambda square divided by mu into mu minus lambda. Okay, substitute the values of lambda and mu, then we will get the average number of customers in the queue. LQ is equal to 8.1. Option A is the right answer. Next, in a shaping operation, one double stroke comprises of cutting stroke and the return stroke. Okay. The velocity of cutting stroke is 12 millimeter per minute. The most probable velocity of return stroke will be, okay, for the shaping operation, velocity of cutting will be less with compared to velocity of return stroke. So from the options we can find the velocity of return stroke. The velocity of return stroke will be more than 12. The only option is C. That will be equal to 15 millimeter minute. That is the right answer. What is the shape factor of a hemispherical body placed on a flat surface with respect to itself? Okay. First we need to draw one figure on hemispherical body placed on a flat surface. We need to consider the number we need to give is 1 and hemispherical body is 2. Suppose 2. We need to calculate, we need to find the F22. Okay, the shape factor of the hemispherical body with respect to itself. Okay, F22 we need to calculate. First, we know that F21 plus F22 will be equal to 1. Okay, and F11 plus F12 is also equal to 1. So F11, the horizontal surface, the flat surface is, because of the flat surface, the shape factor of the flat surface with respect to itself is 0. That is F11 is equal to 0. From that we will get F12 equal to 1. Okay. Another one equation is F12. Another one relation between F12 and F21 is the multiplication of F12 with the with A1 will be equal to F21 into A2. Okay. From that also we can find the F21 value, that will be equal to 0.5. Substitute the F21 value to the first equations. From that we will get the hemispherical shape factor of the hemispherical body with respect to itself will be equal to 1 minus 0.5, that will be equal to 0.5. The answer is C, 0.5. Thank you.